Good morning friends, welcome to the series of Joint Entrance Examination JEE Mains 2019. Dear friends, this exam consists of 3 subjects, that is mathematics, physics and chemistry. Each subject you will get 30 questions. Each question carries 4 marks. If you choose correct answer, you will get 4 marks. That means total of 90 questions into 4, you will get 360 marks. If you choose all correct options, you are going to get 360 marks. If you take a wrong answer, you will lose minus 1 mark. That means there is a negative marking system. If you take one negative answer, you will lose 1 mark. So today we are going to solve 10th January 2019 Shift 2 paper of JEE Mains 2019 chemistry paper. How many questions will be there? 30 questions. So let us see the solutions of this chemistry paper. Question number 1. The ground state energy of hydrogen atom is minus 13.6 electron volts. The energy of second excited state helium plus ion in electron volts is, they have given options minus 54.4, minus 3.4, minus 6.04, minus 27.2. Let us see the solutions. Dear friends, we know that to know the energy of any excited state, we have an equation En equal to E ground of N of hydrogen and Z square by N square. What is Z? Z is atomic number, N is energy level. Dear friends, here helium it is asking, they are asking helium. What is the Z number of helium? Yes, it is 2. Then what is the N? They are asking second excited state. Dear friends, when atom is at ground state, N is 1, ground state is 1, N equal to 2 at first excited state. If it is second excited state, then the N is 3. So substitute these 3. What we are going to do? So E third helium place equal to minus 13.6 electron volts into 2 square by 3 square, that is 4 by 9 into minus 13.6 electron volts. If you multiply this, you will get minus 6.04 electron volts. So the option number 3 is correct option, friends. What is the option? Minus 6.04 is correct answer, friends. The ground state energy of hydrogen atom is minus 13.6 electron volts. The energy of second excited state helium plus ion in electron volts is minus 6.04. Next, question number 2. Hemoglobin and gold sol are examples of. Dear friends, we know hemoglobin is a positively charged and gold sol is a negatively charged. Yes, what about others? Charged salts respectively. Option 2, positively charged salts. Option 3, negatively charged salts. Option 4, negatively and positively charged salts respectively. No, friends. The option number hemoglobin is positive salt. Rm, that is gold, is a negative salt. That means the option number 1 is correct option, friends. Next, question number 3. The major product of the following reaction is, what is the reaction? Step 1, they are doing starting material with dilute HCl and heating, that is dilute HCl reaction, acid hydrolysis they are doing under heating conditions. Then they are going to do polymerization using oxalic acid. When you treat this methoxy, hydroxy and acetyl compound of phenol, what you are going to get? Yes, friends, there will be a cleavage of this acetyl group. Deacetylation takes place in presence of dilute HCl. Deacetylation takes place to give hydroxy, that is phenol we will get. Next, what we are treating with oxalic acid, there will be 2 catechol type. This is methoxy and this is catechol. 2 hydroxy, orthohydroxy phenols are also known as catechols. So this catechol, upon reaction with oxalic acid, it undergoes polymerization reaction. Is there any effect on this methoxy group with dilute HCl? Dear friends, to do demethylation of this methoxy group, we need strong acids like aluminum chloride. Under this dilute HCl, they are specifying dilute HCl reaction conditions. This methoxy group is not going to cleave. This methoxy group is not going to cleave. So this deacetylation takes place and methoxy group is intact. This option is having methoxy group, other options are not having methoxy groups. Let us see this option. Is there any relation? So this is not methoxy. So this, where it is acetyl is here. No, demethylation will not go. So here it is demethylation is taking place. So the polymer is correct, but demethylation is taking place. Here also no, demethylation will not take place. So the option number 1 is correct, friends. Option number 1 is correct option, friends. Next, question number 4. The amount of sugar, what is sugar? C12H22O11 required to prepare 2 liters of its 0.1 molar aqueous solution is So what is the molarity formula? Weight by molecular weight into 1000 by V. Just substitute the values. 0.1 molarity, yes, they have given. Weight by 342, yes, 342, what it is? It is the molecular weight of sugar, C12H22O11. How to calculate? This is molecular weight of carbon is 12. So 12 carbons, 12 into 12, 144 plus H22. Molecular weight of hydrogen is 1, 22 is plus 22 plus O11. Molecular weight of oxygen is 16. 16 into 11 is 176. If you add all these molecular weights, you will get 342. So weight by molecular weight into 1000 by V. 1000 is here V. How much they are asking? 2 liters. So volume is 2 liters in ml, milliliters. You don't know the weight. When you bring this weight this side, left hand side, LHS, then this equation will be written as 342 into 0.1 much 0.1 molarity. This comes here into 2000. This 2000 goes out up and by 1000. So just simply cut off this 2000 by 1000. It gives 1. That means into 0.1, right? 0.1 into 2, 0.2, 0.2 into 342. What is the answer? 68.4. The required sugar amount is 68.4 grams of sugar is required to prepare 2 liters of its 0.1 molar aqueous solution. This is a very simple, friends. If you know the equation of this molarity equation, weight by molecular weight into 1000 by V, this is very important. Please remember this, just by heart it. Just by heart it. Molarity equation is very important. It have its role in total chemistry, organic, inorganic and physical chemistry. So please by heart this. Next, question number 5. Among the following reactions of hydrogen with halogens, the one that requires a catalyst is usually hydrogen plus any halogen. If you mix it, simply it forms acid, hydrohalo acid. So what are the options they have given? Hydrogen plus iodine, HI, yes, hydroiodic acid, HBr, hydroatomic acid, HCl, hydrochloric acid, HF. So HF instantly it forms. It doesn't require any catalyst. So they are asking the one that requires catalyst. Right? So this HCl immediately forms, HBr immediately forms. Iodine, hydroiodic acid requires catalyst because iodine is least reactive halogen. So its reaction with hydrogen requires catalyst. So option number 1 is correct option, friends. Next, question number 6. 5.1 grams ammonium thiol is introduced in 3 liters evacuated flask at 327 degrees centigrade. 30% of solid, that is ammonium thiol, decomposed to ammonia and hydrogen sulfide as gases. The Kp of the reaction at 327 degrees are equal to 0.0882 liters atmosphere per mole. Molar mass of sulfur is 32 grams per mole. Molar mass of nitrogen is 14 grams per mole. Options are 0.242. Option 2 is 1. Option 3 is 4.9. Option 4 is 0.242 atmosphere square. Let us see the solution. Dear friends, just write the equation. Ammonium thiol is going to give ammonia gas and hydrogen sulfide. How much? 30%, that is 0.3. So number of moles at equilibrium, PV is equal to nRT. What will be the answer? P total 3 liters. What is the amount? 3 liters introduced into evacuated flask, right? So 3 liters, 30%, it is going to give, this is 30, this is 30, right? You will get at equilibrium, simply substitute all these values, you are going to get 0.242, that is 4. Option number 4 is going to be the correct answer. So the option number 4 is correct option, friends. Next, question number 7. The reaction that is not involved in the ozone layer depletion mechanism in the stratosphere is, dear friends, be careful. This kind of questions are very typical. When you do not concentrate on this not option, the reaction that is involved in the ozone layer depletion mechanism in the stratosphere is straight away simply what do you select? Chlorofluorocarbon containing compounds causes ozone layer depletion. So the option number 1 straight away you may choose. But they are asking not involved, so this option is not correct. Difluoro-dichloromethane is involved in the ozone layer depletion, but they are asking not involved, so this option is not correct. Whereas this chloro compound, yes, this is also causes depletion. What about hypochlorous acid? Yes, this also causes depletion. But methane gas, there is no halogens, This is not going to not involved in the ozone layer depletion mechanism in the ozone layer. It is fact that the reaction is not involved in the ozone layer depletion mechanism in the stratosphere is methane plus ozone giving formaldehyde plus water is the reaction which is not involved in the ozone layer depletion mechanism in the stratosphere. So the option number 3 is correct option, friends. Next, question number 8. In the cell, platinum and hydrogen 1 bar, HCl, silver chloride and silver platinum. The cell potential is 0.92 volts. When A 10 to the power of minus 6 molal solution, 10 to the power of minus 6 molal solution, its hydrochloric acid solution is used. The standard electrode potential of silver chloride, silver and chloride minus electrode is simply substitute the values if you know the equation. Anode and cathode are everything is given. Just substitute this 0.06, right? So whatever the values they have given, substitute the values, you are going to get 0.2. So this is the option, 0.2 volts is correct option, friends. What is the option? 0.2 is correct option, friends. Next, 71st electron of an element X, we don't know the element, with an atomic number of 71 enters into the orbital. Here, friends, 71 means this is lanthanide. Lanthanides are F block elements. Just by simply assuming like this, you may choose 4F, but this is wrong. So it is F block element. They are asking 71st electron of an element X with an atomic number of 71 enters into the orbital. What is the orbital? Let us see. What is orbital? If you know molar electron configuration chart, you can write also lutetium. What is the element? 71st electron means it is lutetium element. It is lutetium element. We know that lutetium electron enters into ID. How? Let us see. Let us see. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14. 4f14. How many electrons till now? Right? 1s2, 2s2, let us calculate 2 plus 2 plus 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12, 18, 20, 10, 30, 36, 38, 48, 48 is 50, 56 plus 14, 70. Dear friends, up to now 70. That means 70 electrons are up to here, 4f. So the next coming electron is going to enter into 5d. So here 5d. So 5d, 1 electron, 71 is electron. The 71st electron of an element X with an atomic number 71 enters into the orbital 5d. Answer is 5d. Dear friends, please write down like this and work like this. Then you will get correct option, that is 5d, d orbital, 5d orbital. So the option number 3 is correct option, friends. Next, question number 10. The correct match between item 1 and item 2 is the items compounds are given in item 1 and the reagents are given in item 2. What are the compounds? Lysine, furfural, benzyl alcohol, styrene. The reagents are 1-naphthol, ninhydrin, KMNO4, cetic ammonium nitrate. They have given different combinations. Let us see. Let us work on one by one. Lysine. What is the lysine? Yes, friends, it is an amino acid. Amino acids gives ninhydrin test. Straight away choose this ninhydrin test. We know this. The options having AQ. This is not there. So 3 straight away goes out. Then furfural. What is the reagent? Furfural reacts with 1-naphthol. Benzyl alcohol, yes, gives reagent cetic ammonium nitrate. Just go for styrene. Styrene, yes friends, styrene reacts with KMNO4, the reagent where you can find styrene, right? Because it oxidizes this styrene double bond to benzoic acid. So KMNO4 is the correct option. So styrene, Dr. What are the options? Dr. What about others? Yes friends, these straight away can be taken out, ruled out. Doesn't have any other options. Let us see the options. So lysine is ninhydrin. Next, furfural is 1-naphthol. That means B is P. So C is S. What is C? Benzyl alcohol is cetic ammonium nitrate. Yes friends, benzyl alcohol is cetic ammonium nitrate. That is how you can choose the correct option AQ, BP, CS and DR. This is how lysine is ninhydrin, furfural is 1-naphthol, benzyl alcohol cetic ammonium, that is CAN, styrene KMNO4. So the option number 1 is correct option, friends. Next, number 11. An aromatic compound A having molecular formula C7H6O2 on treating with aqueous ammonia and heating forms compound B. Compound B on reaction with molecular bromine and potassium hydroxide provides compound C. having molecular formula C6H7N. The structure of A is, so what they are going to do, A upon reaction with ammonia is going to form B, and this B upon reaction with bromine and potassium hydroxide, they are getting C. What is the reagent? This is bromine and KOH. Yes friends, the reagent and reaction is known as bromine and KOH reaction is Hofmann's bromamide reaction. That means degradation will take place. So the how many number of carbons are there? C7. What about the product? Yes, C6. So there is a degradation. So to take place Hofmann degradation reaction, what is the starting material? Yes friends, amide. What we need? Amide. Some with ammonia we can get amide. So aldehydes will give imines. Aldehydes will give imines, whereas benzoic acid will give with ammonia. This amide upon reaction with bromine and KOH will give the required product. So that is how a compound, if we take benzoic acid, treat with ammonia and heat it, you will get amide, then bromine and KOH, that is Hofmann's bromamide reaction conditions. Rearrangement takes place and it produces this carbonyl group and gives aniline. Let us see the carbons. So the starting material C7H6, 1 2 3, this is 6 and 1 7, H6, yes, 5 plus 1 6, O2, these are the O2, C7H6 O2, yes, starting material is correct friends. Next product C6, carbons are 6, yes, nitrogens are 5 plus 2 7 and nitrogen is 1. So C is matching and A is matching. So the option number 1 is correct option friends. Next question number 12, process with negative entropy change is negative entropy. Be careful friends, this is the question where they are insisting what is negative entropy. Delta S is negative, they are asking delta S is negative. Dissociation of 1 mole of calcium sulfate to calcium oxide and sulfur trioxide. Dear friends, when something is going to form one molecule to 2 molecules, yes, the entropy change is positive. Sublimation of dry ice. Dry ice is in solid form, it is going to become gas, so the entropy change is positive. Dissolution of iodine in water. Iodine is in solid form, if you dissolve it in water, yes friends, it is also positive entropy. Synthesis of ammonia from nitrogen and hydrogen. What we are going to get? Ammonia is 1 mole. Yes, 1 molecule. This is nitrogen and hydrogen. We are combining 2 molecules into 1. That means entropy is negative. What they are saying? Calcium sulfate to calcium oxide, sulfur trioxide positive. Carbon dioxide to carbon dioxide gas is positive. Dissolution of iodine in water is positive. Delta S nitrogen. Yes, friends. This is 1 molecule and these 3. 1 plus 3. How much you should get? 4. But how much you are getting? 2. You are condensing. So what is the entropy? Negative entropy. So the option number 4, synthesis of ammonia from nitrogen and hydrogen, is correct option friends. Next number 13, an ideal gas undergoes isothermal compression from 5 meter cube to 1 meter cube against a constant external pressure of 4 Newton meter square. Heat released in this process is used to increase the temperature of 1 mole of aluminium. If molar heat capacity of aluminium is 24 joules per mole per K, the temperature of aluminium increases by option number 1 3 by 2K, option number 2 2K, option number 3 2 by 3K, option number 4 1K. Let us see. Dear, know that work done on isothermal irreversible for ideal gas is minus P external, V2 minus V1. Just substitute the values as per the given values. Just you will get heat used to increase temperature of aluminium is Q equal to NCM delta T. If you know the values of this and substitute this, the option is going to be get 2 by 3K. So the option number 3 is correct option friends. What is the answer? 2 by 3K is correct option friends. Next question number 14. Elevation in the boiling point for 1 molar solution of glucose is 2K. The depression in the freezing point for 2 molar, it is 2K. Relation between KB and KF is, we know that delta TB by delta TF is equal to Im into KB. Substitute these values, 2 by 2 goes off, right? So 2 by 2 temperature goes off, but the molality of is changing. So the 2 KB equal to 2 KF. 2 KF. KB equal to 2 KF is correct option friends. Option number 4. Next question number 15. The major product of the following reaction is What is the reaction? Sodium borohydrate reduction. It is a reducing agent. What it is? Sodium borohydrate is a reducing agent. What it reduces? It reduces carbonyl compounds to alcohols. Then what else? It reduces imines to amine. But it will not reduce alkenes or alkynes to alkanes. So the question is sodium borohydrate reduction of carbonyl compound, alkene and imine. Where it is going to work? It is going to work on alcohol. Yes, ketone to alcohol, this alcohol, this alcohol, this alcohol. Okay, fine. What about double bond? Double bond, will it going to reduce? No. So this is no, alcohol, but double bond is reduced here. So this option is not correct. Then next, what? Imines to amine. So double bond will be there, but imines to amine. That means option number 4. It reduces imine to amine and ketone to alcohol. Imines to amine? No friends. So this is also not correct. So the option number 4, that means sodium borohydrate reduces ketone to alcohol, imine to amine. So the option number 4 is correct option, friends. Next, question number 16. Sodium metal on dissolution in liquid ammonia gives a deep blue solution due to the formation of, so what is the metal? Sodium metal in liquid ammonia. What is this reaction? Usually we do this kind of reaction. Yes, Birch reduction. Sodium metal in liquid ammonia. Why do we get blue color? Deep blue color. Sodium ammonia complex, sodamide, sodium ion ammonium complex, ammoniated electrons. Dear friends, color comes due to ammoniated electrons. It is known that reason of color is ammoniated electrons. So the option number 4 is correct option, friends. Next, question number 17. For an elementary chemical reaction, E2 is 2A. The expression for dA by dt is, what is the expression? Yes friends, it is very simple. Directly you can take 2k1a2 minus 2k minus 1 a2 square. That means option number 4 is correct, friends. Next, question number 18. Which of the following tests cannot be used for identifying amino acids? Dear friends, amino acids identification test. What is the test? Just now we saw ninhydrin test. So they are asking cannot be used. Dear friends, again please follow these keywords. They are asking cannot be used. Yes, ninhydrin test can be used, but they are asking cannot be. Biuret test, yes, it is used for amino acids. Xanthoprotic test, yes, the test itself is showing protein. That means it is used for amino acids. So this is also not correct. Barfoed test, dear friends, Barfoed test cannot be used for identifying amino acids. It is used for to detect the presence of monosaccharides, to especially reducing sugars in solution. So the option number 2 is correct option, friends. What is the option? Barfoed test. Next, question number 19. The difference in the number of unpaired electrons of a metal ion in its high spin and low spin octahedral complex is 2. The metal ion is cobalt 2+. We see high spin and low spin octahedral complexes in cobalt 2+. That is, the difference will be 2+. Nickel, iron, manganese, no friends. So the answer is the difference in the number of unpaired electrons of cobalt 2+ octahedral complex in its high spin and low spin octahedral complex is 2. It is, so the option number 3 is correct option, friends. Next, question number 20. The major product obtained in the following reaction is, what is the reaction? They are using some base, sodium methoxide base, and heating, and the starting material is carbonyl compound, is having alpha hydrogens. There are carbonyl compounds having alpha hydrogens in presence of base under heating reaction conditions gives alkenes. What is this reaction? Aldol condensation reaction. Let us see what is the reactive positions. Yes, this is also one reactive position, alpha to carbonyl. This is alpha to carbonyl. This is also alpha to carbonyl. This is also alpha to carbonyl, and this is also alpha to carbonyl. There are 5 reactive centers. When compared to carbonyl and ester, which is more acidic, this will be the acidic. So this ester, alpha to ester, is ruled out. So this is ruled out. Here it is not going to take place. Whereas this alpha to carbonyl compound, if this going to attack here, yes, there is chance 1, 2, 3, 4, 5 carbon chain, but inside the ring there will be strain of this carbonyl. There will be a strain of this. So this and this is not going to form. Is there any chance to form this alpha hydrogen? If it is taken, this is, so this side only 1 carbon, this is 3 carbon. So forming 3 carbon chain is very tough. So this is also not going to form. So 3 and here Is it going to form? It is also a 3-member ring. It is very tough. Next remaining is 4. So this is the center where we can abstract the proton with sodium methoxide to give an ion. It is going to form an ion. It is going to form here. It is there will be 2 hydrogens. It is very simple, friends. The 2 hydrogens, sodium methoxide will take out this hydrogen, right? So we'll take out this hydrogen and this bond moves here. It becomes minus ion. This minus ion goes here and attacks here to make it as alcohol. So CC bond formation takes place. There will be alcohol, there will be alcohol, right? So there will be alcohol. Before this reaction there will be alcohol, yes, and this hydrogen will be here, this hydrogen will be here. So there is no double bond now. When we heat this mixture, this loses water, minus H2O, then this gives double bond, this gives double bond, this gives minus water, this gives double bond compound. So the option number 4, friends. So the option number 4 is correct option, friends. The major product obtained in the following reaction, that is aldol reaction, we are going to cyclize these. So this carbonyl is here, this carbonyl is going to form double bond, and this ester is here, so this carbon is here. So the option number 4 is correct option, friends. Next, question number 21. The pair that contains 2 pH bonds in each of the oxo acids is, what are the oxo acids? They have given all phosphoric acids, H4P2O5 and H4P2O6, H3PO2 and H4P2O5, H3PO3 and H3PO2, H4P2O5 and H3PO3. If you know the structures of these phosphoric acid or phosphorus acids, you can straight away you can give the answer. Let us see. H3PO2 is having hypophosphorus acid. This is also known as hypophosphorus acid, is having 2 pH bonds. How many pH bonds we require? This is 1 and this is 2. There are 2 pH bonds. So H3PO2 is going to be the correct option. H3PO2 is here. Yes, here also H3PO2. Next, pyrophosphoric acid. This is pyrophosphoric acid is nothing but H4P2O5. He is also having 2 pH bonds. So where are they? This is 1, this is 2. There are 2 pH bonds. Phosphorus acid, H3PO3. What is H3PO3? How many are there? There is only 1 pH bond. When you take H4P2O6, hypophosphoric acid, how many pH bonds are there? 0. There is the option having H3PO2 and H4P2O5 is going to be the correct answer. So the option number 2 is having H3PO2 and H4P2O5, that is hypophosphorus acid and pyrophosphoric acid are having 2 pH bonds in each of them. So the option number 2 is correct option, friends. Next, question number 22. Which is the most suitable reagent for the following transformation? Let us see. 1, 2, 3, 4, 5, 6. 6 carbon to 1, 2, 3, 4, 5. So 1 carbon less, that means this is going to be cleaved and alcohol is going to become acid. What is the transformation? Toleranz reagent? No, friends. Ammonical silver nitrate? No. Iodine sodium hydroxide? Yes. Iodoform? Let us see other reagents. Bromyl chloride? No. Alkaline KMnO4? No. This reaction, alkyl hydroxy compounds group gives a positive test with iodoform. This is iodine and sodium hydroxide by converting into acid group. So the option number 2 is correct option, friends. Next, question number 23. What is the IUPAC name of the following compound? Straight away they are asking, friends, IUPAC name of this compound. How many carbons are there? 1, 2, 3, 4, 5 and 6. 6 carbons are there. So as per IUPAC nomenclature rules, you have to choose the longest chain which is having high number of carbons. 1, 2, 3, 4, 5. Yes, friends, let us see arbitrary numbering. 1, 2, 3, 4 and 5. 5 means it should be either the nomenclature should be pentene. Right. So the option number 1, butene, straight away strike off. Option number 2, propene, straight away strike off. Next, option number 3, 2-bromo 3-methyl pent-3-ene. Right, friends, 2-bromo 3-methyl pent-3-ene. So pent-3-ene. When there is a competition between substituents like this and alkene, always alkene gets more priority and it must be given least numbering. So the numbering, if I start from here 1, 2, 3, this alkene is going to get 3 ene. Here it is given, but as per rules, IUPAC rules, the alkene group must get lowest number. That means this is the way we have to follow 1 2 3 4. By following this 1 2 3 4 method, we are going to get 4 bromo. Yes, this is a 4 bromo, 3 methyl, this is a 3 methyl, 4 bromo, 3 methyl, and pent 2 ene. 4 bromo, 3 methyl, pent 2 ene. What is the position of alkene? 2 position. So pent 2 ene. Option number 4 is correct option, friends. So the compound nomenclature of IUPAC nomenclature of compound is 4 bromo 3 methyl pent 2 ene is correct option, friends. Next question number 24. The number of 2 center 2 electron and 2 electron and 3 center 2 electron bonds in diborane respectively are 2 and 1, 4 and 2, 2 and 2, 2 and 4. Dear friends, if you know the answer straight away, you can choose the answer. That is 2 center 2 electrons are 4 and 3 center 2 electrons are 2. Let us see by knowing the structure or by drawing the structure. Yes, friends, there are in diborane 2 bridge bonds are there. How many is 3 center 2 electron bond and 4 terminal bonds, 2 center 2 electrons. There are 4 terminal bonds are there. And how many are there? 1, 2, 3, 4. There are 4 2 center 2 electron bonds. Yes, friends. Whereas 3 center 2 electrons, we know this is 3 center special bond in diborane. What is boron gives this, provides this electron, and this electron is provided by this hydrogen. But this pair is shared by this boron, and this boron. So 2 electrons are shared by 3 centered. So 3 atoms are sharing this 2 electrons. Whereas these two electrons, one of them is given by this boron and this electron is given by this hydrogen. So it is shared by 3 centered. This is the special bond, is also known as bridge bond, or this is centered 2 electron bonds. How many are there? This is 1 and this is 2. So the option having 4 and 2 is correct option, friends. Option number 2 is correct option, friends. Next question number 25. In the reaction of oxalate with permanganate in acidic medium, the number of electrons involved in producing one molecule of carbon dioxide. Let's see how many oxalates are required. Yes, friends, 5 oxalic acid molecules. Yes, with KMnO4 of 2 moles of KMnO4, presence of acid, they are going to 10 carbon dioxide molecules. 10 carbon dioxide molecules. Right, friends. So how many carbons are there in this reaction? So in starting material there are 2 into 5, 10. So how many carbons are coming out here? Yes, 10. Means if 10 electrons are transferred to 10 carbon dioxides, then what about one molecule of carbon dioxide? How many electrons are going to involve? Only one, friends. One electron involves to per molecule of carbon dioxide transfer of electron is 1. So option number 1 is correct, friends. Next question number 26. A reaction of cobalt 3 chloride and ethylene diamine in 1:2 mole ratio generates 2 isomeric products, A violet colored, B green colored. A can show optical activity, okay. B is optically inactive. What type of isomers does A and B represent? What are they? So there are 2 isomers, A and B. One is violet colored, other one is green colored. A and B, but one is showing optical activity, other one is showing inactivity of optical activity. What are these? 2 isomers with one is optical activity and another one is optical inactive. What may be the isomers? Option number 1 geometrical isomers, option number 2 coordination isomers, 3 linkage isomers, 4 ionization isomers. What is the answer? Geometrical isomers. Let us see the structures. Yes, friends, 1 mole with 2 moles of ethylene diamine is going to form dichlorobis ethylene diamine cobalt 3 chloride. What they are going to form? These. So this is the compound A, violet in color, and this is cis compound. This is cis compound which is active, optically active, whereas green color B compound is inactive. This is trans compound. What are the compounds? Cis compound and trans compound. On cis trans isomers are geometrical isomers. Cis trans isomers are geometrical isomers. So the option number 1 is correct option, friends. Cis trans isomers are geometrical isomers. So the geometrical isomers option is correct option, friends. Next question number 27. The electrolytes usually used in the electroplating of gold and silver respectively are. So it is straight away question, friends. If you know the answer, yes. So what is the electrolyte? Rm cyanide and silver cyanide. So the option number 1 is correct, friends. Cyanides, chloride, hydroxide, ammonia, no, friends. So the option number 1, cyanide, is correct option, friends. It is fact that the electroplating of gold and silver are done using electrolytes of gold and silver are Rm cyanide and silver cyanide. So the option number 1 is correct option, friends. Next, question number 28. Compound of formula A2B3 has the HCP lattice, that is hexagonal closest packed lattice. Which atom forms the HCP lattice and what fraction of tetrahedral voids is occupied by the other atoms? Dear friends, if A is forming HCP lattice, then what about the tetrahedral voids of B by the other atoms? Imagine B producing HCP lattice. Total number of atoms in B is given as 3. Okay, B3. Tetrahedral voids occupied is 2n. Yes, what is the here? N is 3. That means THV is 6. Okay, no problem. Now number of atoms in A is, let's say Z, we don't know. THV is 2. Yes, is equal to Z into 6 equal to 2. Z equal to 2 by 6. That is, now we know that Z equal to 1/3 and THV is 6. Just substitutions. So if you bring this Z here, THV, then A by 1 by 3 into 6 equal to 2. That is, A is 2. A is 2. So 1/3. Based on this formula, the tetrahedral voids is going to taken place by A is 1/3, 1 by 3. If A produces HCP lattice, so what about, just go through this. So what is this tetrahedral voids? 3 by 4. So if I do this total number of atoms in A is 2, THV occupied is 2n, that is N is equal to 2, THV is 2 into 2, 4. Now number of atoms in B is equal to Z prime into THV is equal to 3. It is given B is equal to 3. It is here equal to Z prime into 4, that is 3, right? Z prime is equal to 3 by 4. Now we know that Z prime is equal to 3 by 4. When we know Z prime is equal to 3 by 4 and THV is equal to 4, then B equal to nothing but 3. Here it is, B is matching, 3 is coming. So if HCP lattice A is formed by A, 3 by 4 tetrahedral voids should be taken by B. Is there any option? 3 by 4 B, 3 by 4 B, 2 by 3 B, no. So this is not correct. 3 by 4 B, 1 by 3 B, no, this is also not correct. 3 by 4 B, 3 by 4 B, not there. HCP lattice formed by B, 1 by 3, this is 2 by 3, no. So this is the option which is showing correct option. HCP lattice is formed by B, 1/3 tetrahedral voids of A will be occupied. So the option number is correct option, friends. This is how you can solve this question 28. Next, number 29. The major product of the following reaction is, what is the reaction? So they are doing the reaction with aqueous NaOH in first step, and second step they are treating with methylated. So this material, it is orthocresol. R is the phenol. Yes, sodium plus. Yes, so this phenol will form a salt with sodium ion. Sodium hydroxide is strong base, so with sodium hydroxide forms sodium phenoxide. This is sodium phenoxide, friends. It forms sodium phenoxide. This sodium phenoxide in presence of methylated, what it will do? So what is this? Methyl iodine will take minus charge, partial minus charge. There will be a positive charge, and this is nothing but negative charge. This oxide ion will take up this methyl, and total there will be minus of sodium iodide. What is going to happen? Methylation of phenol. So methylation of phenol is taking place. Total reaction is methylation of phenol, that is methoxy group is forming. What is the option is showing? Methyl is intact, methoxy is here. What about other compounds? This is hydroxy is clear, methylation, no, this is not going to take place. Ortho, para, meta, no, friends. If you do Friedel-Crafts alkylation, then this is possible, but this is sodium hydroxide reaction. Here alkylation will not take place, here it takes place, that is methylation of hydroxy group. So the option number 2 is correct option, friends. Next, question number 30. What will be the major product in the following mononitration reaction? Mononitration reaction, what is going to happen? Nitrating mixture. Yes, friends, we are using nitrating mixture, sulfuric acid and nitric acid, and doing nitration of this benzoanylate. This is benzoanylate, this is aniline portion, this is benzoic acid amide, right? So this is benzoanylate. Usually we do this aniline with acetylation product, that is acetyl group. but here they have given benzoylide, estanyl instead of estanyl they have given benzoylide, no problem. So when they are doing nitration, we know that benzoylide is orients nitro group to ortho para, so this is known. It orientation of nitro group will be ortho para. If it is instead of NH, if there is NO2 withdrawing group, what is the orientation? Yes, it should orient meta position. Meta dinitro compound will get meta position. So is there any option to go meta position? Is there any option? Nitro to meta. So the option which is having meta position of benzoylide is straight away you can strike off. It is not going to be the correct answer. Next, about this ortho and para, is there an ortho compound? There is no ortho compound. So para compound, is there any para compound? Para to, no friends, this is not the correct answer. Benzoic acid para, benzoic acid ring, it will not take place. So para to this, yes, this is the option. Option number 4, para nitro compound will be para nitro benzoylide. We will get para nitro benzoylide as a major compound. There will be some portion of ortho compound, there will be a mixture of ortho and para. So they did not given all those options. So the major product of this reaction, what we are going to get is para nitro benzoylide. So the option number 4 is correct option, friends. Thank you, friends. Thank you for watching this video. Please subscribe my channel if you are not yet subscribed, and don't forget to click on like button and bell button. All the best to your exam. Bye. Ta-da.
Perfect.